Hello everyone. Today we're on to our third integration technique, partial fractions. If you encounter an integral involving a rational function with no obvious way forward using substitution or parts, this may be what you need to do. It's a bit of work up front, but the integrals themselves are actually pretty easy, so let's try a few. Starting with this one, x plus 5 over x squared plus x minus 2 is a little bit difficult to guess and check, but we can factor the denominator into x plus 2 times x minus 1, which we can further express as a sum of two simpler rational functions, something over x plus 2 and something over x minus 1. Now to figure out what a and b are, it would be helpful to multiply both sides of this equation by x plus 2 and x minus 1. So on the left side of this equation, the x plus 2's go away and the x minus 1's go away as well. On the right side of the equation, we need to distribute this into both terms. So with the a, the x plus 2's cancel, and we'd have a times x minus 1. And with the second term, the x minus 1's would cancel, and we'd be left with x plus 2 times b. So we have a times x minus 1 and b times x plus 2 equals x plus 5. Now if x equals 1, a times 1 minus 1 would go away, that'd be 0. And we'd have b times 1 plus 2, which is 3, and that equals 1 plus 5, which is 6. So we have 3b equals 6, and therefore b equals 2. Now if x equals minus 2, you can see the second term on the left side of the equation would disappear. So we would have a times negative 2 minus 1, which is negative 3, plus 0 equals negative 2 plus 5, which would be 3. So we have negative 3a equals 3, so a is negative 1. So therefore, we can express this integral, x plus 5 over x squared plus x minus 2, as a sum of two simpler rational terms. So we found that a was negative 1, and that was over x plus 2, and we found that b was 2, which was over x minus 1. And by the properties of integrals, we can split this up. So with one integral, we would have negative 1 over x plus 2, and the other one would be 2 over x minus 1. Now we can write the coefficients of each of these integrals out front. So we would have negative integral 1 over x plus 2 dx plus 2 integral 1 over x minus 1 dx. And now these integrals are straightforward to do. It would be negative ln of x plus 2 plus 2 ln of x minus 1 plus c. So this example involves a rational function that can be expressed as a sum of two or more rational functions with denominators that are non-repeating linear binomials. In general, when using the technique of partial fractions for integration of rational functions, we will always express the rational function as a sum of simpler rational functions. So let's try another one out. We've got 3x minus 20 up top and x squared minus 5x on bottom. So we can factor this rational expression a bit. We'd have 3x minus 20 over x squared minus 5x is equivalent to 3x minus 20 divided by x times x minus 5. So like the last example we did, hopefully we can write this as a sum of simpler rational functions, a over x plus b over x minus 5. Similar to the last example, we'll multiply both sides of this equation by the factors on the bottom, x and x minus 5 in this case. So on the left, all that remains is 3x minus 20, and on the right, we get a times x minus 5 plus b times x. Now if x equals 5, 3 times 5 is 15, and 15 minus 20 is negative 5. And on the right, we have a times 0 plus b times 5. So this gives us that b equals minus 1. And if x equals 0, on the left, we have 3 times 0 minus 20, so that's negative 20, equals a times negative 5 plus b times 0, which is 0. And if we divide both sides of this equation by negative 5, we get a equals 4. So now we can write our original integral as the integral of 4 over x dx plus the integral of negative 1 over x minus 5 dx. And those are simple enough to do. We would have 4 times ln of x minus ln of x minus 5 plus c. And for our last example of the day, the denominator of this integral can be written as x times x minus 1 times x minus 1, or if you prefer, x times x minus 1 squared. Now hopefully we can write this original function as a over x plus b over x minus 1 plus c over x minus 1 squared. Now in order to figure out what a, b, and c are, we multiply both sides of this equation by x times x minus 1 squared, giving us on the left side 2x squared plus 3, and on the right a times x minus 1 squared plus b times x minus 1 plus c times x. Now if x equals 1, we would have 2 times 1 squared plus 3 on the left, which would be 5, and then we have a times 1 minus 1 squared, so that would be 0. The b term would go away as well, because we would have b times 1 times 0, and the c term we would have c times 1. So from that we get c equals 5. And now if x equals 0, the left side of the equation above gives us 3 equals a times 0 minus 1 squared. So 0 minus 1 is negative 1. Negative 1 squared is 1. A times 1 is a. The b term would be 0, and the c term would be 0. So this scenario gives us a equals 3. Now in order to figure out what b is, we can rework this a little bit. So we would have 2x squared plus 3 equals a times x squared minus 2x plus 1 plus b times x squared minus x plus c times x. And now we can distribute the a into each of these and the b into each of these, and we can group our x squared terms. So we would have 2x squared plus 3 equals a plus b times x squared plus negative 2a minus b plus c times x plus a. So when we look at it like this, we can see a is equal to 3. All of these terms need to go to 0, and we need a plus b to equal 2. So if a plus b equals 2, and we've already established that a equals 3, 3 plus b needs to equal 2, and therefore b equals negative 1. And now we can see our original integral can be written in the following way. 3 over x plus negative 1 over x minus 1 plus 5 over x minus 1 squared. You can confirm for yourself that this is true by graphing the left-hand side and the right-hand side of this equation, and you'll see that they match completely. And now we can rewrite our original integral as 3 integral 1 over x dx minus the integral of 1 over x minus 1 dx plus 5 integral of 1 over x minus 1 squared dx. These first two integrals are fairly straightforward, so that would be 3 ln x minus ln of x minus 1. This third one we can do by substitution if you like. So you could substitute u equals x minus 1, and therefore du equals dx. So the integral of 1 over x minus 1 squared dx would be rewritten as the integral of 1 over u squared du. And u squared you could think of as u to the minus 2 if you prefer. And the integral of u to the minus 2 would be u to the minus 1 divided by minus 1 plus c. So this third integral would work out to be minus 5 over x minus 1, and we should also have a constant of integration. That's it for me for today. I'll get you to try this one out on your own, and I'll see you next time.